Hello everyone, and thank you for joining us here on this Friday for our webinar, Intro to M1, the hardware. We're going to be going over the M1 controls, expanders, and accessories today. My name is Amy Strickland, and I'm with our Tech Support Department. Joining me today is Brad Weeks, who is the manager of our Tech Support Department. So we're going to be going over the M1 controls and letting you know what the M1 can do for you, the features and benefits. We're also going to spend a good deal of time going over all the different hardware and how things wire and hook up, and going over data bus wiring and that sort of thing. So throughout the presentation, if you do have questions, we would encourage you to ask those questions. There's a questions box in your GoToWebinar control panel. If you can just type those questions in, we'll be able to see your questions, and we can go through just as many of those as we can during the session. We'll ask those questions and give you the answers that you are looking for on those. If we are not able to answer your question, maybe it's more involved and we need to follow up with you afterwards, or maybe we just run out of time because there's a lot of questions, which that wouldn't necessarily be a bad thing if we had more questions than we could answer, but we will follow up on that after the webinar. That follow-up is generally sent out Monday morning or midday Monday, and that will include a summary of the question and answer session from the webinar, a copy of the presentation that we're using, a link to the recording of the webinar, and some other resources that we think you may find helpful. So we'd like to start out the webinar by asking you a question. We're going to be launching a polling question here on the screen, and if you could just take a moment to answer that question for us. We just want to see how familiar you are with the M1. We just want to get a feel for the audience that we have today. We're going to leave that up for just a few more seconds. Really appreciate everyone answering the question there for us. So just a few seconds, and then I'll close that poll. Okay, thank you for answering the polling question. It looks like just about half of our audience today is not familiar with the M1 or has not installed a system yet. We have quite a few people who have installed one or two systems, and then just a few of you with us have installed several systems. So for those who are new to the system, hopefully this will let you know what the M1 can do and give you some ideas of how you get started with it. And for those that are maybe more familiar with the M1, maybe you'll learn something that you weren't aware of that it can do, that sort of thing. So that's our goal here, is to make this as beneficial for you as possible. Okay, so let's start talking about the M1. We refer to the M1 as a cross-platform control. So what that means is that it's kind of like compare it to, say, a universal remote, where you have one control that can operate a number of different subsystems. So the M1 provides the security. It's rock solid, full-featured security system, but then also incorporates automation for things like lighting, energy management, access control, and we can also do home and business control through a number of different user interfaces and like your smartphones and computers and that sort of thing. So this just kind of gives you a general overview of what can be integrated, and we're looking at a home here, but keep in mind as we're going through this, while the M1 is definitely great for residential applications, it can also be used in a number of different commercial applications. So you keep that in mind, especially when you're thinking about the access control and that sort of thing. Those could definitely cross over into a commercial application as well. So again, the M1 provides security. We can also control things like lights, fans, small appliances, thermostats, whether they be some hardwired thermostats that we work with or some wireless thermostats, so you do have both options there. We can control things like electric water heaters, pumps. We have a water shutoff valve that can be controlled through the M1 and tied in with leak detection devices. We can control, garage doors and gates, and also, looking at again at the access control. And then some of our partners also offer shades and blinds that can be controlled from the M1 as well. So let's take a look at the two different systems that we have to offer. We're going to spend a lot of time today talking about the M1 Gold, but we do also have a control called the M1 EZ8, which is kind of like the little brother to the M1. So just to give you kind of some comparison there, the M1 Gold has 16 onboard zones and expandable to 208 total. 144 of those zones could be wireless. In comparison, the EZ8 has 8 on board and can only go up to 200, but again could have the full capacity with the wireless of 144 zones. Outputs on the M1 Gold, you have 13 on board, and that can be expanded up to 205. The EZ8 has 12 on board and can be expanded to 204. Now, there's one output difference there, and that output is actually the voice output of the system. So the M1 Gold has a voice output, which is output 1, and that allows the system to make on-site announcements for various events and different scenarios, and you also have a built-in telephone remote control with the M1 Gold. Those features are not available and cannot be added to the EZ8. Another thing that the M1 Gold can do that the EZ8 can't is the two-way listening, which is used by Central Station for alarm verification. With the M1 Gold, you can have that two-way listening for that alarm verification, and it's also possible to initiate a listening session through the telephone remote control. You do not get those features with the EZ8. Features that are common to both systems are the 6 arming levels, so you have away, vacation, stay instant, night, and night instant. And it is programmable in such a way that you would be able to configure which of those arming levels your customer has access to, so you can make it simpler for them if they're not going to be using the night instant mode. You can take that out so that they don't have to see that or be confused by it. Both systems can support up to 199 users, a user being either an arm-disarm code or an access credential, whether that be a code or a card or a fob, or even biometric devices have been integrated in with the M1. So up to 199 users. Up to 8 areas or partitions or accounts for the Central Station, just depending on how you want to look at that or what your terminology is, but you can break the system out into 8 different sections or areas, and your zones and keypads and that sort of thing get assigned to one of those areas. The event log holds 512 entries, and both systems have a built-in astronomical clock so that it can tell, sunrise, sunset, light, dark conditions, that sort of thing. So we have 6 different types of keypads that connect to the M1 data bus that you can use to interface with the system. And so your customer really has a lot of choices there as far as the keypad that fits their style and their decor and what their personal preferences are. We also have the little arming station, which is great for areas where you don't necessarily need a lot of information, but you want to have some way to interact with the system. So you can see the M1 KP is the original keypad with the contoured shape, the green LCD. That keypad has a door. We also have the M1 KPB, which is the same keypad just with a blue LCD. The M1 KP2 is a very popular keypad. That's the rectangular shape, no door on that one. And the KP3 is similar to the KP2 but with a door. And then of course one of the very popular keypad options is the M1 KP Nav, or what we refer to as the Navigator keypad, which is a small touchscreen keypad. Now you can mix and match those keypads however you like. You can have up to 16 of those. Here's a comparison chart, and I'm not going to go through every line item on this, but just know that we will be providing a copy of this presentation to you in the follow-up email so that you'll have that, so that you can have comparison of the size of the keypads, how many F keys they have, which ones support proximity readers, and that sort of thing. Now, as I mentioned a little bit earlier, the M1 can be controlled from a number of different remote control applications. So we offer a piece of software called M1 To Go, which is for Windows, and that is a free download from our website. So that's definitely a good place to start for remote control, because you can just download it for free and use it and see how you like it. There are also apps available. So eKeypad is for the iOS platform, for like your iPhone or your iPad, and that's a family of apps. There are different different levels of that, or different versions of it that provide different levels of interface to the system. So, you know, one option is to just control security stuff, or if you really want to get into all of the automation and say also incorporate maybe some video, then there's a version for that as well. M1 Touch Pro is for Android devices, whether that be an Android phone or tablet, and so that's going to be your one app for Android. And then Connect One is a cloud-based service that allows you to interact with any web-enabled device. So they have you know, computer app access as well as apps for both the iOS and the Android platform. The Connect One does require a monthly fee. The other options that I was covering do not require a monthly fee. The eKeypad and M1 Touch Pro apps are sold through the respective marketplaces through third parties. So you do have to purchase those apps, but it's a one-time purchase. So we've been talking about all the different things that the M1 can integrate with and control, and we do that through a you know, integration-friendly approach and having partner manufacturers out in the industry. So we work with a lot of familiar companies that I'm sure you've heard of in the industry for various you know, lighting or thermostats or, you know, third-party interfaces, that sort of thing. So this screen just gives you kind of an overview of that. We do have an integration partner section on our website that outlines each one of these partners, and you can learn more about the partner, what it does, and also how the M1 is able to interface with that partner, the hardware that's required, and other resources. So you'll find that all online. So we have different kits for the M1 Gold, and again, that's the control that we're going to be focusing on throughout this presentation. The kits are, you know, set up so that you can choose different keypad options, or whether or not you want the 14-inch enclosure, which is standard with the kits, or, you know, some kits do not have that enclosure, so that you can either get our 28-inch enclosure, or if you happen to need something even larger than that, you can use a different enclosure with the system. We also have our two-way wireless ready kit, which includes the wireless transceiver, and the price point of that kit basically allows you to get that wireless transceiver for free. It also includes a key fob, so then you can add all the other two-way wireless devices that you need, and we'll be going over those in more detail as we go out through the presentation here. Okay, so that was just kind of a basic overview. We're going to step now into system layout and expansion, but I did see a question that came in that I wanted to go ahead and address very quickly. It was about ceiling fan control, and basically the way that that's working is through one of the lighting partners. You could have a you know, a switch that would be able to turn that fan on and off. That's, you know, the basic idea there. So at this point, I'd like to turn it over to Brad Weeks, and he's going to go over some wiring and installation system layout stuff with you.
Everyone, we certainly do appreciate you taking time out of your busy schedule to join us today for our webinar. And right now we're going to start with a little system layout and expansion overview. And we certainly hope by the end of today your installation goes a lot better than this poor gentleman here in the bottom of our slide. Looks like he is definitely not having a good day. So to get started, let's take a look at the main control. And what we're looking at now is the M1 Gold system. This is our M1G, and on the upper left-hand side of the circuit board, you'll notice this is our 16 onboard zones. Below that, we have our AC input and our auxiliary DC voltage outputs. We have our master on-off switch, have our battery leads. At the bottom of the black plastic housing that the M1 is housed in, there is a white barcode sticker that includes the serial number for the M1 system. This is a unique 8-digit number that's never been duplicated. For the M1 Gold, it'll start with 0. For the M1 EZ8, it'll start with 4. And it's an 8-digit number that you'll need when you use the RP software to connect to the system. So each M1 system has its own unique serial number. In the upper right-hand corner of the circuit board, we have our standard hardwired landline telephone connection. We have our onboard RS-232 serial port. We have outputs 7 through 16. Below that we have outputs 1 through 3. And then we have our RS-485 data bus connections. Now these green terminal blocks are removable, so if there ever is a case where you need to take the M1 out for some reason, you don't have to disconnect the wires, you don't have to disconnect the battery. You can use the remove the terminal strips without having to remove any additional wires. Now the zone inputs on the M1 system, each zone can be configured to support the end-of-line supervised, or it can be just simply normally open or normally closed. If you do use the end-of-line supervised resistor, it is a 2.2 k ohm resistor, and it should be installed at the furthest point on the loop, at the sensor itself, for proper supervision. If you're thinking of putting the resistor inside the enclosure, then I would suggest just making the zone normally closed and not using the resistor, because you lose your supervision on the zone. And the way this supervision works is it's a voltage divider, and at the M1 it'll see approximately 7.5 volt there. If something should happen between the M1 and the zone, let's say somebody accidentally put a staple or a screw or a nail through the wire, the zone is shorted, that would be a zone trouble condition to the panel. If the resistor is inside the enclosure at the panel and somebody put a staple, nail, or something through the wire, the M1 would never know. So if you're using the end-of-line resistors, they should be at the furthest point at the sensor itself. But the M1 is flexible, so you can configure to use either normally open or normally closed contacts, which would not require the resistor at all. Each zone on the M1 system does share a negative with its neighbor, so every zone has a common negative between the zone beside it. Zone 16 on the M1 system is the only zone that will accept a 2-wire smoke detector, and that 2-wire smoke detector must be listed on page 6 of the M1 installation manual. You can daisy chain up to 20 detectors together, and at the last detector you'll have an 820 ohm end-of-line resistor. This is different from the regular sensors in that they use 2.2 k. The 2-wire smokes use an 820 ohm. There's a jumper right under zone 16 which must be set to either normal or 2-wire depending on what detector you're connecting to the zone. The system will support 4-wire smoke detectors, and any zone can be configured to accept a 4-wire smoke, including hardwired input expanders. So you have more flexibility with 4-wire than you really do with 2-wire. Now on the M1 Easy 8 system, this would be zone 8 instead of zone 16. The M1 system will support hardwired temperature sensors, and what we're looking at right now is our new M1 ZTS, our zone temperature sensor, in its new housing. And if anyone has seen the older model, I think you'll really appreciate the newer and more modern looking design. I mean, this would obviously be somewhere probably visible, so this really fits in nicer with most decors. The ZTS has the zone temperature sensor built into the housing. You can get a remote sensor in the M1 ZTSR. The 7-foot probe connects to the interface, and that 7-foot probe can go into a little harsher environment, let's say like a freezer or something of that nature, wine cellar, outdoors, things like that. So we can monitor the ambient temperature either around the interface or the 7-foot probe. 7-foot probe is weatherproof but not waterproof, so it should not be submerged into liquids. We can monitor a temperature from -50 up to 120 degrees Fahrenheit. These do connect to the main board, so you can have up to 16 of these connected to the system. So zones 1 through 16 will support a zone temperature sensor. The hardwired zone input, our M1 XINs, will not accept the zone temperature sensor. And speaking of the hardwired zone expander, this is the M1 XIN. It is a 16-zone input expander. There are dip switches on the board to set the address, and that address will determine your starting zone bank. So you can add up to 192 additional zones using 12 expanders. These connect to the M1 data bus, so they could be located at the control, or they can be remotely located if it's more feasible to have the input expander located in a different area of the facility or the home or anywhere on the M1 data bus. And you can add up to 12 of these to the system. The M1 system does support wireless, and out of the total 208 wireless zones available, up to 144 of those can be wireless. So right now we're looking at our ELK M1XRF-TW. This is our two-way product line. The M1XRF-TW is our wireless transceiver, and we call it a transceiver because it can send and receive signals to our two-way wireless devices. Our ELK two-way wireless devices give acknowledgement back to the transceiver that the signal was received. So right now we're looking at going to the right. We have our 60/40 glass break sensor. It has all of our sensors have an LED built into them, so that once the signal is received, the LED would turn green to indicate that the signal was accepted by the transceiver. The 60/40 is our glass break. We have our ELK 6050 smoke detector, and we call it our sound all smoke detector. It has a built-in sounder, and if the detector goes into alarm, sends a signal to the M1 sends a signal to the other 6050s to start sounding as well. So all of your smoke detectors would go off at one time with their built-in sounders. Now, if the M1 goes into alarm, let's say from a hardwired smoke detector or a fire panic on the keypad, again, all of the 6050 smoke detectors would go into alarm and start sounding at one time. I don't believe any other wireless technology incorporates in that feature. So it's a wonderful feature for the M1 system. We have our 6011 single button panic. We have our 6023 recess sensors, and we also offer that in a brown color now. We have our 6010 4-button key fob. And this is the new design. This is a new look. It does have a replaceable battery capability now. And once again, the 4-button fob has an LED on it, and once the signal is received, you can check the status of the system by pressing the third button, which we call the inquiry button, has the eye on it. You press that. If the LED turns green, the system is disarmed. If it turns red, the system's armed. If it's flashing red, that means the system has been in alarm. So it's a great visual indication before walking into the residence. You want to check the status, or if you've just walked out of the residence and couldn't remember if you armed or disarmed, we now give you a way to check the arm-disarm state of the system, as well as has it been an alarm. We offer our 6020. This is our slimline window door sensor. We offer that in a white and a brown. We offer our ELK 6021, which is our mini window sensor. It's a very small, compact sensor, recommended for vinyl and wood only, not recommended for metal. We have our 6022, which is a universal 3-zone sensor. This is actually 3 zones in one. You can have your built-in reed switch with the external magnet. You can also hardwire 2 additional zones to this sensor, so you get 3 zones out of 1 transmitter. And then we offer a motion detector, the ELK 6030, which is also available in the PET Immune, the 6030P. If you'll notice on the motion detector, we've also included a LED, we call it a courtesy light, and that can be controlled through the RP rule engine. It also turns on when the system goes into alarm and so forth, so it lights the way if necessary. Don't believe any other wireless manufacturer has offered a courtesy LED into their motion detector. It can be used as a night light, things like that. Somebody walks in front of the motion, turns on, that way you're not turning on additional lights and so forth. All of our sensors have the built-in status acknowledgement LED, so it's a great troubleshooting tool also if you're setting up a system and you're not quite sure if you're within range of the transceiver. If you trip the sensor and the LED turns red, we know we're out of range, at which point you can either relocate the transceiver to a more centralized location, or you can add up to 3 more of the ELK M1X RFTW transceivers to the data bus, and that will help increase the coverage area or help to eliminate any of those weak signal strength areas or dead zones. It doesn't increase the total number of zones. You still have up to 144 wireless zones. Also, if anyone has recently heard about other manufacturers of wireless technology, they use a single band frequency. The ELK two-way wireless is a frequency hopping, which means that we spread the spectrum between 902 and 928 megahertz. So we're not constantly transmitting and receiving on one single frequency. We're jumping around, which makes it more difficult to try to detect what frequency the sensor is on. It also makes it more difficult to jam our sensors. Unlike the single band frequency manufacturers, which if there was a recent ABC News article where an individual with the correct software was able to detect a frequency and basically disable the wireless in the home. He was able to tell the security system the zone was actually closed when it was open. He could arm and disarm the system from his laptop. So it's the ELK two-way wireless being frequency hopping, more difficult to try to detect and jam and defeat our wireless system. And we do also offer other wireless options with the M1 system. We do integrate with the Honeywell 5800 series. This is one way only, so it's basically the sensor transmits and hopes that the signal gets through to the receiver. We also integrate with the GE and GE supported formats. Right now we have the M1XRF2H to support Honeywell. We have the M1XRF-EG to support GE transmitters. Like I said, you can have multiple multiple receivers on the data bus to help increase the coverage area, but you're still you can only have up to 144 wireless zones. Now the power connections on the board are made in the lower left-hand corner, and the first terminal there is the S-aux terminal. This is our switched auxiliary power terminal. It's primarily used for 4-wire smoke detectors or any other detector which would need power removed from that device once it went into alarm in order to unlatch the device. Through the keypad you can perform this, what we call the smoke power reset. It's a keypad function, in which case once that was activated it would drop power off of the S-aux terminal for 5 seconds. below the S-aux terminal, we have the V-aux. And there's 3 terminal points here. And this is for powering your peripherals, like your motion detectors, your glass breaks, things of that nature, which require 12 volt. We give you 3 convenient locations here to land your wire, so you're not trying to squeeze all those motion detectors under 2 terminals. You can now divide up the wiring there and spread out the load. It is the same terminal point, so it has the same onboard PTC fuse. We just give you 3 areas for convenience. The AC terminal input on the board, that's where we'll connect our ELK TRG 1640 transformer. It's a step down to 16.5 volt AC, 45 volt amp transformer. It's included in the kit, and this is what powers the M1. We have our master on and off switch, which is a convenient way to turn off both the AC and the DC power to the board. So if there is a need to shut the system down, there's no need to disconnect the battery. We simply move the switch into the off position. And if you'll notice, on our board in the very lower left-hand corner are 2 little solder pads right there. And this is a convenient way to jump start the system on DC power only. See, it's a new construction. The AC hasn't been finalized yet to the site, but you want to test the system. So you can connect a battery to the M1, move this on-off switch into the on position, and short across these 2 terminal points, and it'll power up on DC only. So you can make your final connections and do your testing and get everything set up, waiting on the AC to be installed at the site. The battery connections on the M1 are for charging up to an 18 amp hour sealed lead acid battery. But if you need more power, we offer the ELK P212S remote power supply. Its AC and battery are supervised over the M1's data bus, or it can be a standalone power supply. It'll have its own 16 volt transformer, the ELK TRG 1640, just sold separately, and you can add a battery to it as well, up to I believe it's 12 amp hour battery on the 212S power supply. It's 12 volt DC output at 2 amps. So if you have a large system and need additional power, then the 212S supervised power supply would be a great solution. There's also a programmable output on the board that you can use through the RP rules. So let's say, for instance, we need to drop power off of some remote 4-wire smoke detectors. We could do that through the RP rule engine. Now the telephone line connections on the M1 in the upper right hand corner, this is hardwired landline copper telephone connection, standard, using an RJ31X jack. The incoming phone line should be the first thing that the M1, it connects to the M1 first, and then the house phones downstream for proper line seizure so the system can communicate to the central station. Now the M1 is always connected to the phone line. It's always monitoring the phone line. So through the automation rules, we can tell when a phone goes off hook. We can tell when the phone is ringing and things like that. So the M1 is constantly monitoring the phone line. And because it's always on the phone line, we highly recommend that you incorporate telephone line surge suppression into your install. And we include the ELK 952 surge suppressor in the kit. And you can see in our little block diagram here, it's real simple to install the 952. More than likely you're already going to have your RJ31X and your 8-pin modular cable back to the control, so you simply put the 952 in the middle between them. And it's very important to ground the 952 so that it operates the most efficiently it can. So any surge within its rating will get dissipated through a earth-ground connection. Now the earth-ground should be a driven ground rod or metallic cold water pipe, or worst case, third option would be the electrical AC ground to the residence. Now the M1 system has two-way listening capability. This is primarily for central station verification on alarms. This helps to avoid unnecessary dispatch of the authorities or emergency service personnel due to false alarms, somebody burning the toast or whatnot, which in some cases can lead to fines in some areas, and those fines can be pretty expensive. So with the two-way listen-in, Central Station has the ability to listen into the residents and to talk, and then the residents have the ability to communicate back. It's also possible to call into the residents using the M1 Gold over using our telephone, remote telephone capabilities, so that you can also check on elderly if that's the scenario, and without them having to get up and answer the phone, you can access the two-way listen-in function, listen in and speak, make sure everything's okay with Grandma today, and disconnect and or not have to worry about getting up and answering the phone. We can support up to 12 microphones on 3 separate zones. Now, what we have at the bottom of our screen are our two-way listen-in interfaces. We have the M1 TWA, which is our amplified interface, and the M1 TWI, which is just the standard interface. The difference between the two is the M1 TWA, you can connect your speakers to this module, and you can control the volume to those speakers. So if you have a multi-level home, for instance, the upper level may be the sleeping quarters, and the volume of the spoken voice may not need to be as loud in that area or versus what's the living area, where it may need to be a little louder. With the TWA interface, you also have the capability of muting those speakers. Like I said, for sleeping quarters, or maybe it's near a baby's room, you want to mute those speakers during normal activity, when the M1's talking, speaking zones are open and so forth. So we're not disturbing the area, those individuals in that area. But when the system goes into alarm, those speakers become unmuted. So the M1 TWA has several nice benefits to it. The volume control, being able to connect your speakers and microphones to the one interface, as well as having mute capabilities. The M1 TWI, you simply connect your microphones to this board, and the volume output through the speakers is controlled by the M1. We offer several different speaker microphone combinations. We have the M1 TWS in the upper right-hand corner. It's a speaker microphone surface mount only. We have the M1 TWSF speaker microphone flush mount into a single game box. And then we offer the M1 TWM, which is the microphone only. Now the M1 does have the capability of communicating over a hardwired landline telephone to Central Station. We support Contact ID, SIA, and 4+2 format. But you can also have alternate reporting methods in cellular communication, because we can integrate with the uplink 4500 EZ. Now to do so would require the M1 XSP, our serial port expander, and there's a special firmware update for the XSP to communicate with the uplink. There's also a special cable from uplink that would need to be obtained to connect it to the XSP. We can integrate with the AES and Telenet radio. Once again, it takes the XSP module. There are also a number of dial capture devices on the market today which simulate phone line voltage and current to a security system, and the security system sees the phone line, dial the number, transmit data. The dial capture module would capture this information, turn around and relay it out through their network. We also support IP alarm monitoring, which would require the M1XEP, our Ethernet module. And at this time, we are compatible with the DSC SureGuard 3 and the Osborne Hoffman 2000E Central Station receivers. Several different methods for communicating alarm signals through the M1 system. Now the main serial port on the board is located in the upper right-hand corner. It's an RS-232 port. It's used for programming the system with the RP2 software, which you would do a direct serial connection or a USB to serial connection from your computer. It also allows the M1 to interface with some third-party software devices like Crestron, Control4, and so forth. You can connect the XEP module to the main board here on serial port 0, and that allows the M1 to be connected to the local area network or accessed through the internet. So when the M1 is connected to the local area network, multiple devices can connect to the system over the local area network, RP, those third-party software or touchscreens and so forth. But once RP connects, it takes hierarchy over the connection, so those other devices would be suspended during that, their communication would be suspended during that time period. In the block diagram at the bottom, the serial connection between the M1 and the third party or the M1 and the XEP is an RS-232 connection. It does use 3 pins, pins 2 to 2, 3 to 3, and 5 to 5, so it's a straight through connection. And the maximum distance you can run that length of cable is 50 feet. Typically we would like to see the XEP module mounted into the enclosure next to the M1, kind of like you see here in our picture diagram. And then the XEP connects to the local area network through a standard Cat5 patch cable. XEP, like I said, is used to connect the M1 to the local area network for programming, or it can be accessed through the internet for remote programming. It is a secure connection with the PC and the apps. It uses the secure port and encryption. It also supports email and text notification, internet monitoring and reporting, and URL updating using a dynamic DNS provider. And you can sync the system with a national time server. So the M1 is always within just a few seconds of the national time server. It keeps the date and time up to date. Looking at the outputs on the board, output 1 is for the interior speakers. This is where your voice and your siren is generated for inside speakers. You can have multiple speakers connected to output 1 as long as you keep the overall load between, say, 4 and 16 or 4 and 32 ohms. So you can connect those in a series parallel combination. And this is where your spoken voice and your siren sounds are generated for interior use. The M1 has a lot of voice capability built into it. Each zone, all 208, can have up to a 6-word phrase assigned to them, and the M1 has a 500-word vocabulary. So a lot of different menus there that can and options which can be spoken when zones are open, when the system's arming, when it's disarming, and when it goes into alarm. Output 2 is a supervised siren output, typically used for exterior sirens or speakers. It's programmable that you can use the M1's built-in siren driver. There's no spoken voice through output 2, it's just siren sounds. Or you can switch it to a voltage output for a self-contained siren, in which case the output is rated at 12 volt DC at 1 amp. So make sure if you're using a self-contained that you don't exceed that 1 amp current rating. If you're not planning on using output 2, it's important to put a 2.2 k ohm resistor across output 2 positive and negative to prevent that output 2 trouble condition. Output 2 is supervised, so it's always expecting to see a load there. And it's important to use the 2.2 k and not a direct short. Direct short will damage the board. So make sure you're using a resistor there. Output 3 is a general purpose Form C relay. It's used, it's programmed through the ELK RP rule engine. It can be used to switch 12 volt to 24 volt DC up to about 4 amps. So if you want to control self-contained siren, or if you would like to control a strobe or something along that line, or just use it as a general purpose dry contacts or maybe a garage door controller. Output 3 is built onto the board and programmed using RP. Outputs 7 through 16 are voltage outputs. They're positive switch, 12 volt at 50 milliamps each. They too are programmed using the RP rule engine. And you can set those up to be triggers upon alarms, arming or disarming, maybe to control an LED or something, to visual status. There are many different applications you could use those for. You can also convert outputs 9 through 16 to actual relays using the M1RB. This is our relay board, plugs directly onto J16 there, and it converts 9 through 16 into general purpose Form C relays. And we offer an output expansion board for our data bus called the M1XOVR. This adds up to 8 physical relays, Form C relays, as well as 8 low voltage outputs. So you have a total of 16 outputs on this one board. If you would like to convert these 8 low voltage outputs into Form C relays, you can add an M1RB to this board. We include a wiring harness to connect it to, and now you have 16 Form C relays. And these are great for garage door controls, sprinklers, pumps, or just LED indications. And the last connection on the M1 is the M1 RS485 data bus. Now, it is a true RS485 data bus. It communicates at 38,400 baud rate. And it's important to make sure that the proper wiring of the data bus is followed and proper termination of the data bus. And we're going to go through some data bus examples. You can have up to 2 home runs coming off of the M1, in which case you could daisy chain devices together, making sure not to exceed 4,000 feet for your total run. I mean, going from the M1 out to the furthest device, and then the M1 to the next furthest device on your 2 home runs. The total distance shouldn't exceed 4,000 feet. The last device on each home run will have a jumper. It's a black jumper we include in the hardware pack to engage a 120 ohm resistor. So that would look like 2 120 ohm resistors in parallel on the data bus, which should, if you measured it, should be between about 60 and 70 ohms, depending on the tolerance. And that's a properly terminated RS485 data bus. Like I said, we can have 2 home runs, in which the last device on each home run would have a terminating jumper. You could have 1 home run coming off of the M1, and once again, daisy chaining devices. And the M1 itself has a 120 ohm resistor built onto the board. It's engaged using the JP3 jumper right above the plus VKP terminal on the data bus. So if you have only a single home run, the control's terminated and the last device. If you have 2 home runs, the control's basically in the middle, then you would terminate the last 2 devices on each home run. Now, a lot of individuals may not like daisy chaining, and they may prefer to home run back to the control. So we've offered the M1 DVH Hub, and this is the one here on the left, and it will accept Cat5 home runs back from your device to the M1, and is terminated at the hub using an RJ45 plug. You can have up to 8 devices, actually 9 devices connected to the hub if you wanted to. You can actually series hubs together, so you can keep going from one hub to the next. And what the hub does, it takes the data A and data B, and it keeps that daisy chain going through the hub. So we have data A going out to the device and then back to the hub, which on the next port will go out to the device and back, and the same for data B. So the M1 DVH creates the daisy chaining for you. Now, because we have a return path for the data, the overall data bus, if using a DVH, cannot exceed 2,000 feet. Because now we have the return path, so we have to take into consideration that double length now. The ELK M1 DVHR is for retrofit installs which may have existing 4-wire home runs and it's not possible to rewire them. You can use the retrofit hub in existing 4-wire home runs. Once again, there's 4 branches, and each branch on the retrofit hub, it's basically its own RS-485 data bus. And the retrofit hub is an active device, and it's basically the traffic cop to manage all the data coming from the devices back to the M1. Whereas the DVH is a passive device. I mean, the daisy chain is done internally on the circuit board. So with the DVHR, 2 home runs per branch. Each branch would be terminated properly. There's also some terminating jumpers on the retrofit hub if you're only using a single. Like I said, basically each branch is its own 485 data bus. It's important to make sure that the retrofit hub is mounted as close to the M1 as possible within the same enclosure. Tremendous amount of data going back and forth between the retrofit hub and the M1. We want to make sure we keep that length as short as possible. So let's talk a little bit about wiring devices for the DVH. Like I said, the DVH is the passive hub. It accepts Cat5 wiring or Cat6. Each device will terminate with an RJ45 plug. And as you can see right in our diagram here, we're wiring to a keypad. We have our brown wire, which is power, going to the red wire on the wiring harness for the keypad. We have our data A going to the device on the orange, solid orange, and returning to the hub on the solid green. Data B is going to the device on the white orange and returning on the white green. And then negative for the device is the white brown wire. This diagram, while we're showing a keypad here, also applies for the input expander, the output expanders, the wireless receivers, the serial port expanders, basically anything that wires to the M1 data bus, and you're going to use the data bus hub, the wiring would be the same at the device. Alright, so we're going to take a moment here and take a little pop quiz. So in this example here, where do you think the terminating jumper should be? Take a moment. All right. And if you said A and C, you would be correct, because this is a single home run coming off of the M1. It's daisy chaining 2 keypads together. The keypad itself will be terminated using one of the black jumpers supplied, and the JP3 jumper will be terminated at the main control. So if you said A and C, you'd be correct. I'm going to mix things up a little bit. In this example, where do you think the data bus should be terminated? Because we have now 2 home runs coming off. We're daisy chaining 2 keypads on this top home run. We're daisy chaining input or output boards together on the bottom home run. Where do you think the terminating jumper should be located? All right, if you said A and B, okay? Or A and F. Sorry,
C and F.
Yeah,
C
yeah,
and
C
F.
and F. C and F, sorry. C and F, you would be correct, because this is 2 home runs, so the keypad and the last device on the other home run would be terminated. Alright, so now we're going to use the data bus retrofit, the data bus hub. This is the passive hub using the RJ45s. Once again, we have a single run to the hub, and we've connected multiple devices to our hub. Where do you think the terminating jumper would be located? All right, A and G. A, because we have the one single home run coming to the hub, and G, because it's the first unused port. So this, we include a terminating plug that has the resistor built into it, and that would plug directly into J6 in this example. Our next data bus example is using the retrofit hub, and this one gets a little bit more complicated, so take just a little bit of time here, examine this. We have one home run coming to the retrofit hub, and then we have these other devices connected. So we'll take a moment here to review. All right, let's review your answers here. First, A is terminated because it is a single home run going to the retrofit hub. B is terminated because, once again, this is the only run between the two. So this engages a 120 ohm between the retrofit hub and the M1. We'll look at branch 1 here. We have a single home run daisy chaining devices together, so we terminate the last device, and we terminate the retrofit hub. Branch 2, we have 2 home runs. Each device gets terminated, but not the hub. On branch 3, once again, 2 home runs, a single device here, 2 devices daisy chained there. Because it's 2 home runs, the last device on each home run would accept a terminating jumper, but not the hub. And then finally, on branch 4, it's a single home run going to a device. The device gets terminated as well as the hub in this case. All right, well that includes my portion of it right now. Do we have any questions, Amy?
We do have a few questions. So one of the questions that we have is related to voice over IP, and I know you had mentioned some of the alternative ways of communicating if you're not able to communicate over a phone line. We've had sort of hit and miss results from various customers and even within our own staff here who have tried voice over IP lines on the M1. So it's not guaranteed that it won't work, but it's certainly not guaranteed that it will. It's one of those things that you're just going to have to try, and if you have a problem with the system reporting over voice over IP, then look at one of those alternates. But it does seem to be regional and varies based on the different service providers and the different types of voice over IP or digital lines. So as I said, no guarantee that it will or will not work. You will just have to try it. But if it doesn't work for you, there are the alternatives, using the cellular or the IP communications. So another question here is related to updating the system. So the LCRP software gets updated as well as firmware for the controls and the various peripherals. We do offer those updates as downloads from our website, and also if you're running a current or recent version of ELK-RP, there's a check for updates option there. However, if your system is running and working correctly and you're not having any problems out of it and you're not trying to incorporate some new feature, we would recommend that it be left as is. If it's not broken, don't try to fix it. So that's our motto on the updates. But updating is done through the ELK-RP software. There's an update option through your send receive menu. There's an enroll update screen that populates all of the devices that are part of the system, shows you the current versions, and would allow you to update those should you need to do that. Let's see, another question here. I think we may have hit on this when it was related to telephone line hookup, which you went over pretty extensively, so hopefully that one is cleared up for that individual. If you're having an issue with wireless lost transmitters, whether that be with the two-way wireless or some of the other wireless options, the most likely culprit of that is going to be a range issue or some type of interference is causing that transmitter not to be able to check in. So there is a way that you can go through the system and put it in walk test mode from the keypad, which is menu 3. And when you have it in that walk test mode, you're going to be able to test your sensors, and you will get an audible notification, an audible announcement there for the level strength. So that's going to be 1 through 8. We would consider anything 4 and above to be good, but of course the higher that number is, the stronger your signal strength is. So you may want to put the system in walk test mode if you're having a problem with the transmitter, and just see, you know, if it has like a low strength reading there, then you definitely want to consider adding a redundant receiver to increase that coverage area. We will be having a webinar on April the 24th, which will cover the ELK-RP software that we definitely mentioned numerous times today. So if you're interested in learning how to use that software to program all of the hardware expanders and features that we discussed today, please be sure to join us on April the 24th. We will send a link in the follow-up email so that you can sign up for that webinar. And even if you're not able to attend that particular live session, go ahead and sign up anyway. That way you'll get the link to the recording that we provide after the webinar's over. Now next week we will be at ISC West. Our booth number is 6035, so if you're going to ISC West, please be sure to stop by and check out our booth. We're going to be showing all of the new two-way stuff that Brad was going over, so you can see that equipment in action, as well as some other new products that we have out. So you definitely want to stop by and check us out. We have a lot of show specials, and there's even a giveaway, so it's definitely we would love to see you at the show, so be sure to stop by. And we have run out of time here today, so we do want to thank you for attending. Thank you for giving us some of your time here on this Friday, and hopefully you learned a lot from this webinar. And if you do have any questions maybe that you didn't think of while the webinar was going on, please be sure to send those questions to us. training@elkproducts.com is a great email address to use for that. Anytime you have questions, just be sure to shoot us an email. We are on social media, so you connect with us on Facebook, Twitter, and LinkedIn. And also, please go check out our YouTube channel. If you want to take it to the next level, you know, before we have another live session, you want to learn more about the M1, or maybe there's something specific that you're going to need to dig into for an installation that you're doing sometime soon. We have a lot of great videos on our YouTube channel that are going to go over a variety of more advanced subjects, so please be sure to check that out and subscribe to our YouTube channel so that you can see our new videos as we post those. Hope everyone has a wonderful Friday afternoon and a lovely weekend. I want to thank Brad for being with us today and helping us out with the training, doing such a great job as he always does. And again, everyone have a great weekend. Thank you.